Hi guys, this video is on Sturm's Conoid, an important short and answer question, and also it's important to understand astigmatism. So, first we have to learn that in spherical lenses, the rays will converge to a single point. So, if this is a spherical lens, the rays will come and they will converge to a single point. But if it is a toric surface, like an astigmatic surface, here there are two principal meridians, mainly horizontal and vertical meridians. So, due to these two principal meridians, they will have different refractive powers also. So, there will be two focal lines. Instead of a simple focus, there will be two focal lines. So, if it was a spherical lens, there will be a simple point focus, a single point. But if it is a toric surface like an astigmatic surface, since they have two different refractive powers and two different meridians, they will have two focal lines, not a point. So, what is Sturm's conoid? Sturm's conoid is a 3D configuration. It is a three-dimensional configuration formed by the bundle of light rays passing through the toric surface. So, we studied that the toric surface has different meridians, mainly horizontal and vertical meridian. So, they have different refractive power. So, when this bundle of light passes through this toric surface, there will be 3D configuration, a three-dimensional configuration which you are seeing here. So, this Sturm's conoid is of bundle of light passing through the cornea with the rule astigmatism. So, this eyes is having with the rule astigmatism. What is with the rule astigmatism? We already studied in the astigmatism that it is vertical meridian is steeper than the horizontal one. So, in with the rule, vertical meridian is steeper. Against the rule, horizontal meridian was steeper. So, we are studying astigmatism of with the rule. This Sturm's conoid is of with the rule astigmatism where the vertical meridian is steeper. So, this red line is representing the vertical meridian while the blue line is representing the horizontal meridian. Okay. So, the light rays are traveling from anterior to posterior direction. So, there are sequence of events happening. First one is oblate ellipse or horizontal oval. What does this mean? This means that the vertical rays are converging faster. We know that in with the rule astigmatism, vertical meridian is steeper, so the vertical rays will converge faster. So, in the first one, that is horizontal oval, the vertical rays are converging faster than the horizontal one. Okay, horizontal is also converging, but this is converging faster than the horizontal one. So, since this is converging and this is converging faster than the horizontal one, we will get a horizontally oval ellipse. So, that is the first one, that is oblate ellipse or horizontal oval ellipse, where the vertical rays are compressing the bundle, they are converging faster. Next one is the first focus or the anterior focal line. What is happening here? Here, the vertical rays focused, okay, but the horizontal rays are still focusing. Third one is horizontal oval. Horizontal oval means the vertical rays after focusing started to diverge while the horizontal rays are still converging. Okay, so that is why here again a horizontal oval is seen. And next one is a circle of least diffusion where the vertical rays are diverging and the horizontal rays are converging, but the horizontal rays convergence and vertical rays divergence are equal. So, convergence is equal to divergence, and this is the point where we get the sharpest image. Next one is vertical oval. Vertical oval means the vertical rays are still diverging and the horizontal rays are converging to the focus. It is reaching close to the focus. So, we got vertical oval. Next one is the second focus, that is the horizontal rays converge and they focus while the vertical lines are diverging, that is the second focus or the posterior line. Last one is the prolate ellipse or vertically oval ellipse where the vertical rays are diverging and the horizontal rays started to converge, so we will get a vertically oval ellipse. So guys, this was Sturm's conoid. First one is horizontal oval, second one is anterior focal line or the first focus where the vertical rays converge. Now the vertical rays start diverging while the horizontal rays are still converging. Then what happens, the divergence is equal to the convergence. Then this is all going to converge. Horizontal one is going to converge while the vertical one is still diverging. Then we got the second focus, that is the posterior focal line where the horizontal rays converge and the vertical rays are still diverging. Last one, the horizontal rays and the vertical rays are diverging. So here we have to remember that there is a focal interval of Sturm. What is focal interval of Sturm? It is the length between two focal lines. So we have an anterior focal line and we have a posterior focal line. So this focal interval is the length between these two focal lines. Then there is circle of least diffusion, that is our CLD, where the diversion was equal to the convergence. So here is the point where we get the sharpest image, and this will be mostly dioptrically in the midway between the anterior focal line and posterior focal line. So this distance is known as what? Focal interval of Sturm, and the midway portion there the convergence is equal to divergence, we will get a circle of least diffusion, and that is known as circle of least diffusion. This was all about Sturm's conoid. I think this was useful for you. Thank you.